Here we go. Okay, they give us a function, so that's the same as we've been dealing with in previous packets. On the white note packet, I pointed out that in AP Calculus, when they start talking about limits, they're usually talking about discontinuities. So they're asking us, does this function have a discontinuity? What's different is they don't tell you necessarily where to look for the discontinuity. So you've got to learn how to find it without any extra clues. The clues at the bottom of the page do basically tell us where things are going to happen, but try to disregard those. The whole point is to practice for a test where you wouldn't have the stuff at the bottom. Okay, jumps. The white packet had a note that said jumps only occur in piecewise functions. This isn't piecewise, so I'm done. There are no jumps. The formula is not a piecewise formula. There can't be a jump. Question, please. No worries. So remember this. It's fundamental for the whole year. We have a formula. That's how we find all of the x and y pairs. If the formula is piecewise, what will happen is instead of having one formula to find all the x, y pairs, there will be multiple formulas. So if you turn the page to number 3, that's a piecewise. 3 points. Good question, Kayla. Anybody else? Cool? Okay. Removable. This note, I forgot to tell you. I would take the packet and I would tear off the back sheet. So I laid out the packet specifically so you could do that. You could just detach the last sheet and use it as notes. Okay? Some of these notes are just exact copies of what's on that white packet. The few at the bottom are new. Make sure you get this memorized. No notes on the test. And everybody look at me. Here's something I haven't mentioned before. It's extremely crucial in calculus that you get things memorized long before the night before the test. Because here's what's going to happen. If you haven't memorized this days before the test, when you're testing, your memory will not be strong enough. And you'll be fighting so hard to remember this, you won't be able to solve the problem. You're going to need all of your brain power to solve the problem, not remembering things. So get this memorized. Number 6, it's the same thing as this sign up here. It says if you forget to factor, you're going to fail. We keep factoring. It just keeps showing up over and over again. Factoring will often help us see if the function has a discontinuity. So again, using good notation, you should write on your paper, that's f of x. So I'm going to write f again. But now I'm going to write f in factored form. The top is already factored. But I like to see things spread out as separate fractions. I think it makes solving the problem easier. This is just a personal preference. So I'm going to write 2 fractions being multiplied there. The bottom will also factor. And I'm hoping that there's not hoping, but often there's a matching factor. So sure enough, there is in this case x plus 4 and x subtract 7. So now I'm going to go like this. Questions? Please.
So on the limits, you have to do like equals. Why don't we have to do that like this?
I'm not sure I'm going to answer this very well, so you just keep talking if I don't. What I've tried to illustrate is, so far, I have this formula where the formula for f is this, so these two are equal. And I've tried to show equality by saying, well, another way to write this formula is just like this. So I know f of x equals this as well.
Oh. Okay.
And then I said, oh, f of x could also be written this way.
Okay.
So I am showing equality. Does that make sense? 2 points. Cool. Okay, new note right here. Look at number 7. It says an x-coordinate which causes the y-coordinate to become 0 over 0. That's the x-coordinate location of a removable discontinuity. And I think this is review. Mr. Recti could help me. Does secondary 3 talk about this idea? Okay. So right here, I found an x. If x is negative 4, this will become 0 over 0. And then remember, well, that is really badly written, but that bottom's hard to read. Try again. That's better. When fractions multiply, you just multiply straight across. So 0 multiplied by whatever would be 0. 0 multiplied by 1 multiplied by whatever would also be 0. Please.
Can you do that again?
Huh? So are you okay with the factoring?
Yeah.
Good. So what I'm noticing is, remember, we have a long list of x, y pairs. And I've just found one that's interesting to me. I noticed that if x is negative 4, I'm going to put a negative 4 here, 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 and here. But I'm not necessarily going to calculate all of them. I'm just going to pay attention to what jumps out. What jumps out is this becomes 0. So who cares what this is, because 0 multiplied by 0 by whatever would still be 0. Multiplied by 1 would be 0. So I'm basically just finding the y-coordinate. If this x is negative 4, I'd have 0 times 1 times whatever. That's your question.
Yeah.
2 points. Please.
Does it have to be 0 on the top as well, or does it just have to be 0 on the bottom?
Awesome. So that's the difference between what will be a vertical asymptote versus a removable discontinuity. I always look for the removable first, because these two factors working together don't cause a vertical asymptote, even though there's a 0 on the bottom. Because for that x, there's also a 0 on the top, it's removable. Did that answer your question? 2 for Luke. Anybody else? Cool. And now I go to note 8. So over here I should make a note. Let's see, x equal negative 4. That's the location of a removable discontinuity. Because that's the x-coordinate where the y-coordinate will become 0 divided by 0. Question? The factoring is what reveals it, so make sure you factor. Okay, number 8. An x-coordinate which causes the y-coordinate to equal number over 0. That's where a vertical asymptote is going to be located. So, right here, I note that if I plugged in 7, this would become 0. This would become 11. This would also become 11. So the top's going to be number times number, which is number. I don't care what the number is. The bottom, 0 times 1 times whatever, is going to be 0. So the vertical asymptote is located at x equals 7. Please.
Will there be problems where you have multiple removables or vertical asymptotes?
So I always tell everyone, I want to make sure you know that I really worked hard to get a really good feel for the AP test. But it's like the stock market. I can't predict future tests. But based on the past, like I've studied every multiple choice test that's been made public since 1969. I've looked at every written section since 2003. So in all those years, I have never seen a question where they had more than one.
Okay, great.
Doesn't mean they won't, but I've never seen it. Does that answer your question?
Yeah.
Perfect, 2 points. Anybody else? Cool. Okay, next part. It says find these limits. Okay, finding the limits is really, really easy now because of all the work we've already done. It says find the limit as x approaches -4. Well, that means we want to be looking to see what's happening when the x-coordinate is just a little bit more negative than -4 and just a little bit more positive than -4. That's what we're looking for. We've already discovered that when x is -4 exactly, the result is undefined. So we're not looking there. We're trying to find this limit. So we know this one, this is undefined. Okay, you hear me say this over and over again. This is a formula for finding all the xy pairs. But notice what Kayla said. Remember, every time I say your name, mark down a point, because that's how I learn your names, how you get more extra credit. So Kayla noticed, here's f of x. But this is also f of x, right here. And even better, as long as x never equals -4, my formula for f is even simpler because this is going to equal 1. So I'm going to have just x plus 4 multiplied by 1 over x minus 7. So I can use this formula to find all of the xy pairs except this one, which is already found. Questions? Oh, please.
Is that correct notation? Are we allowed to just say x does not equal -4 and then write it without it?
Perfect. 3 points for Zach. It's perfect. So what I'm saying, Zach, is you can use this f to find any xy pair. This f of x, any xy pair, this one the same. This one has a restriction. This one will find all of them except for the one that we already found. Perfect. Questions? Please.
I'm still just a little confused because on the limit you use the equals f of x to make sure that they're equal to each other. So I just don't understand why you don't equals on those. Do you understand?
Tell me exactly what you want me to write, then I'll be able to understand what you're saying better.
Okay, well on limits, you would have like.
Just tell me exactly what you'd write. Go ahead.
You'd have like limit as x approaches infinity of something. And then you go to the next line to simplify it. And then you do the equals limit of x goes to infinity. So why don't you do that when it's just like a function?
3 points, Andrea. Good question. I'll do my best to answer. If not, keep talking. It really has nothing to do with whether we're doing a limit or we're factoring or it's a function or whatever. It's all about you successfully communicating to the grader when two things are truly equal. And one way that they deem acceptable is to have one line, and then the next line says equal, which says these two are the same. So that's legal. What I'm doing today is just a different style, I suppose. They start out by saying, this formula for f is this. And then I just say, oh, another formula for f is this, so I just put the equal sign there. It's the same as if I had worked straight down the page and done this. See if this helps. Like if I had started with that formula, so they start with this, f of x equals x plus 4 squared divided by x squared minus 3x minus 28. Is that what it is? Is that right?
Yeah.
I could have gone straight down the page like this and just said equal, and then written out the factored version. and it would convey the same thing to the grader. So I just chose to write it over here instead.
Okay.
So it's just, whatever you're saying is truly the same as the other, that's all I'm doing.
Okay, so you don't have to write necessarily f of x again?
You do not.
Okay. Okay.
Now, for this first line I do, because really these are so far apart, if I just put an equal sign, it's a little unclear to the grader what's that equal to. But I don't have to put the f there. Is that what you meant?
Yeah.
Mhm. But if you do, it's okay,
Okay.
because it's still equal to f. Does that answer your question?
Mhm.
3 points. Awesome. Okay, I want to find this limit. I'm just going to use this formula here. Because this formula will find any xy pair except when x is -4. So, if x is close to -4, this is going to be very, very close to 0. This will be very close to -11. But 0 divided by something is close to 0. So this limit is 0. Question, please.
Why did you write f of x is equal to that equation instead of writing the limit of x as it approaches -4?
Oh, so when I started out, I was just factoring to see if I could figure out where the discontinuities are. Then I got to the part where it asked me for a limit. I could have written down on the paper, like I've got this formula, I could have said limit, etc. I just didn't need to because I can do it in my head. So same thing for you. If you can just look at that and go, okay, I know what's happening here. This is my formula for finding all these xy pairs. I need to find these two. So I can just use this formula to do that. Does that answer your question, Tim?
So we're not required to.
You're not required to.
Okay.
2 more points. Awesome. I need to find this limit. This formula looks, oh, wait a minute. X equals 7, that's where a vertical asymptote is located. We've already talked about that. It was on the white notes. Wherever a vertical asymptote is located, the limit will be non-existent. So I'm done. We also talked about how at the location of the vertical asymptote, the value of the function is undefined. That's in those white notes. So, question, please.
Wait, sorry, I'm still a little confused. Because like when you were showing the thing that says f -4, it was undefined, and that was also like this, like it says like -4, it's like 0 over 0, that's undefined. But like, wouldn't 7 be just 0?
So if you have a fraction and you end up with 0 on the top, number on the bottom, the result is 0. If you have a fraction, number on the top, 0 on the bottom, the result is undefined. So when x is exactly 7, we do get a 0 on the bottom, which is also undefined.
Oh, okay. For some reason, I just thought it was vice versa.
No worries. It's very common. 3 points.
What's the difference between non-existent and undefined?
Honestly, for the purpose of our class, all I would remember is this. When they're asking you to find a limit, they're going to want you to use the word non-existent. If they're asking you to find a specific y coordinate, the value of a function, they want you to use the word undefined. So, 2 points to your question. Please.
Wait, how did you get non-existent?
Right here.
Yeah.
That one's straight from memory. The white packet, we talked about how if you have a vertical asymptote at x equals 7, then the left-hand limit, the right-hand limit, and the overall limit are all non-existent for a vertical asymptote.
Okay.
So I just pulled that right out of memory. Does that answer your question? 2 points. Cool. Next one. Let's stop this.